Hello students, welcome back to my class. Welcome back to chemistry online class brought to you by Ighota virtual learning platform. I am your chemistry tutor, Olabisi Olawoye. And today we will be looking at a topic which is chemical reactions and the different types of chemical reaction. At the end of this class, there are questions extracted from past questions which will help you to understand this topic better. So please pay attention as usual and treat the questions by yourself, after which you come back for the solution. Now, chemical reactions. What is a chemical reaction? You would have seen that at times, a teacher will just come around or somebody will come around and say that when two things, this and this react together, this is what will be formed, that will be formed. And then you begin to wonder how they got to know the answer to all this. Now, this is actually a simple method. By writing the chemical equation, you can predict what will be formed and then describe what will be formed, and then from there you will also become a guru. So when you understand the principle behind identifying the kind of reactions that occur and the nature of reactants reacting together to form product, you'll be able to understand how to write chemical equations better. So a chemical reaction is actually a process in which one or more substances, that's the reactants, react together to form one or more products. And one thing about chemical reaction is that they are usually represented with a chemical equations. They usually represent with an equation. And how do we describe a chemical equation itself? And how do we know that a reaction is occurring? A reaction occurs when you start seeing increase in temperature or changes in temperature, changes in intensity, changes in color, and even the appearance of substances. You know that two substances are reacting, or one substance is reacting to give you something else. So a chemical reaction is represented with a chemical equation. And here, a chemical equation itself is defined as a symbolic representation of a chemical reaction in the form of symbols and formulas. You all know that we have symbols that we use to represent different elements, and from there we get their formulae. So I'm going to be using a skeletal representation here, after which I move into details while explaining the types of chemical reaction. So this is a simple method of writing chemical reaction, even though the symbols used here are not the actual symbol of elements. If A reacts with B to form C and D, the A and B are referred to as the reactants, while the C and D are referred to as products. Now, we have different kinds of reactions to show the different reactions that occur. The major ones, though we have other types, but they are still under this major type of reactions. We have combustion reaction. We have synthesis or combination reaction, displacement or replacement reactions, decomposition reactions, and also ionic reactions. So we are going to be treating each of these reactions one by one, looking at their examples. So the first one here is a synthesis or combination reaction. A synthesis reaction, which is also known as direct combination or combination reaction, is a chemical process in which two or more simple elements or compounds combine to form a more complex product. For instance, now I'm going to be explaining here. If A reacts with B, you get AB. I can use a common element. That is, if N reacts, if sodium, this is sodium from the word natrium, reacts with chlorine, I can actually get sodium chloride. But I will not just merge these two together, but I write their ions. Sodium is 11, so we have 2 on the first shell, 8 on the second shell, 1 on outside. So it gives out that one to become +1, and chlorine itself is 17. As the atomic number, we have 2, 8 when arranging it on the orbital 7, which gains 1. And so When they meet together, they cancel out because they have the same number but different charges. And so you end up getting sodium chloride. So to balance the equation, since we have 2 atoms of chlorine here, we have to add 2 here, making chlorine balanced, but that has affected sodium. So we need to put 2 here to make sodium balanced. The next type of equation is the displacement or replacement reactions. And we have different types. We have the single displacement or replacement, and we also have the double displacement or replacement reaction. Actually, there's something we call activity series for metals and even for negative elements. There are some metals that are more powerful than others. Because of their ability to lose electron easily, it makes them more electropositive than the others, and some are also electronegative than the others, meaning that they gain electron easily. Now, a displacement reaction is a reaction in which a more reactive element, those reactive elements are the ones that are more powerful. Maybe they are more electropositive or more electronegative. When this reactive element displaces a less reactive element from its compound, we call it single displacement reaction. This is common in all reactions, like a reaction between a metal and acid to form salt or oxide, to form salt and hydrogen. So in this case now, we have zinc, reaction between zinc and copper tetrahydrosulfate 6. Now, there's something we call the activity series, which is which I'm going to quickly point out here. Popular, that's K, scientists, NA, you can also get this video separately. Potassium, sodium, popular scientists can make, that's magnesium. Azu, aluminium, zinc. In, that's iron. D, that's tin. Low, Pb, that's lead. Humid, that's hydrogen. Contrary, copper. More, that's mercury, Hg. Satisfactorily, that's silver. Good, that's gold, Au. Now you can see the way these elements are arranged. They are arranged based on their electropositivity. The most positive being at the top. The same also is applicable to electronegative elements. So from this equation of reaction, now we can see that zinc is more powerful than copper. You can see hydrogen being placed as part of electropositive elements. So hydrogen here is actually a gas. So if other elements are under, it means those elements are very, very weak. Very, very weak. They are weakly electropositive. So in this case now, it means zinc is more powerful than copper. Copper is under, very, very low in the series, activity series. So we have zinc displacing copper from a solution. So in this case now, zinc carries +2, copper also carries +2, tetrasulfate 6 carries -2. So the zinc can combine with tetrasulfate 6, and because they carry equal charges, equal number but different charges, they cancel out. So we have zinc SZnSO4, positive at the front, negative at the back, and then we have copper left in form of atom. So it's a solid, and this is an aqueous form. The same also happens here. This is called double displacement, in which AB reacts with CB. Here A displaces B, and we have AC being formed, and then B is alone. Now in this case, now we have AB reacting with CD to form AD. A displaces C because C is weaker, and then C displaces B, and so you have this. So in this case now, I'm going to break down them into their ions. These two is actually from barium. We have +2, then chlorine is -1, then this two is from tetrasulfate 6, while this one carries 1. So we have Na +1, SO4 carries -2. So in this case now, barium, one element will displace another. Actually, sodium will displace barium. Sodium is more powerful. You can see it at the second position in the series. So barium is definitely under. So sodium and chlorine react together. Sodium being at the front, reacting with chlorine, so they cancel out to have NaCl, and then barium combines with tetrasulfate 6. Don't forget the principle behind combination of elements by exchanging their valences if they are different, and if they are the same, they cancel out. like this cancels out. So we have BaSO4. All of them are in aqueous form. So this is sodium chloride being formed here and barium sulfate. So this reaction even occur in neutralization reaction, and this one occur in the formation of hydrogen as well. So these are the different ways in which chemical reaction occur: single displacement, double displacement, generally known as displacement or replacement reaction. We also have synthesis or combination reaction. The next one is a combustion reaction. We have a combustion reaction is actually a reaction with oxygen. Reaction of a substance with oxygen is a reaction. If it is a reaction of a combustible material with an oxidizer to give an oxidized product. An oxidizer is a chemical or a fuel required to burn, generally oxygen. And for instance, now we have simple combustion reaction. We also have combustion of organic compound. Most organic compounds are made up of carbon and hydrogen. Now, so the first one here, we are looking at the simple combustion reaction, in which A reacts with oxygen. A is representing any element here reacting with oxygen to give you AO2. So, but one thing I want you to know is that the general product as a result of combustion is water and carbon dioxide gas. But in this case now, magnesium, which is 12, react with oxygen. So magnesium is 2, 8 on the first shell, 2 on the second shell, 8 on the third shell, 2 carries plus 2, which is given out because it needs 6 more to complete its shell, and the oxygen carries minus 2 because the atomic number is 8. This is 12. So we have 2 on the first shell, 6 on the second shell. This one gains 2 more to make it a. So it's, when they gain, they become negatively charged. When they give out, they become positively charged. That's why we have this. So cancelling out, we have, and because they are the same, they cancel out, though with different charges. So we have magnesium oxide. So you can see here now, this is a burning of magnesium ribbon, and it's called combustion reaction. Anytime combustion reaction occurs, we see that it reacts, a substance reacting with oxygen, and it's an oxidation reaction. We also have combustion of organic compounds. Most organic compounds usually contain carbon and hydrogen, and they also react with oxygen to yield carbon dioxide and water. Now I have a general equation of combustion reaction. This will be very, very useful for you. For any organic compound you have, just use this. Let's use an alkane, for instance, maybe butane. Butane is C4H10 from the general molecular formula, which is CnH2n plus 2. 4 is but. 2 multiplied by 4, which is n, if n is 2, plus this 2. 2 times 4, 8 plus 2, that's 10. So where x and y are 4 and 10 respectively. So anywhere I see x, I put 4. Anywhere I see y, I put 10. That is 10 over 4. And this represents the coefficient of oxygen. To give, that is, an hydrocarbon reacting with oxygen will give you water and CO2, but we need to get their coefficient to complete the equation of reaction. So y is 10 here, and 2 here, we have H2O plus x, which is 4 CO2. So we have C4H10 here, and to simplify this, we have 4 times 4, 16 plus 10 O2 to give 5 H2O and 4 CO2. So from here now, we can still go ahead to simplify this as 26 over 4 O2. Cutting it out, we have 13 over 2. So this 13 over 2 O2, we can leave it here as C4H10 plus 13 over 2 O2 to give 5 H2O and 4 CO2. And at times we can break this, we can cut it as 13 over 2 times 2, because it's a fraction, we cancel this as 13. We write it as 13. So after writing, because we have fractions, we have C4H10 plus 13O single equals to 5H2O plus 4CO2. So we can now multiply all through by 2. If you do that, we can get back what we need. So we have C2 2C4 because we are multiplying by 2 to give 13 that we got as a simple value here. By cancelling out 13, 2 and 2, we have 13O2 left. The 2 has been restored because oxygen is diatomic, to give 5H2O and 4CO2. Sorry, 8CO2 and 10H2O. This is just, you can use any other hydrocarbon to represent this, like alkane, any alkane, alkynes, and alkane, because they undergo combustion reaction generally, and you will be able to balance their equation easily. The next equation here is the decomposition reaction, and is a reaction in which a single component breaks down into multiple products. For instance, now certain changes in energy in the environment have to be made, like heat. So we end up having thermal decomposition. We have thermal decomposition and also electricity, which helps in the breaking of bonds of the compound. For example, now the decomposition of calcium triazocarbonate 4, giving out calcium oxide, that's quicklime, which is a major component of cement. So most triazocarbonates, when you heat them, they give out carbon 4 oxide, and they also form oxides, except triazocarbonate of sodium and potassium, that's K2CO3 and Na2CO3. Those ones are not easily decomposed, while others can be decomposed. So you can see this symbol here, it represents heat. When heating calcium triazocarbonate 4, which is called limestone, it breaks down to give you calcium oxide and carbon 4 oxide. We also have, you can see here, triazocarbonate of sodium, potassium, and barium are not decomposed by heat. Also, all other triazocarbonates are decomposed by heat. And even the same is also applicable to triazonitrates. You can see here, I've arranged the activity series here. The triazonitrates of the reactive element, as most reactive elements like potassium, sodium, calcium, magnesium, or calcium, they are triazonitrate, we yield when heated, as maybe potassium triazonitrate, when it is heated, it will give dioxonitrate and also oxygen. For that's reactive, most reactive. Now, from here, now from magnesium to lead, they are moderately reactive. Now, when you heat any of their oxide, like zinc triazonitrate, rather, when you heat any of their triazonitrate, this kind of reaction involves single reactants breaking down to give you different products. This one, when heated now, any of their category will give you zinc oxide. To give you their oxide, give you nitrogen 4 oxide, a brown gas, and also oxygen. While the ones be under hydrogen, these ones, they are the least reactive metals. When you heat them, like copper triazonitrate, for instance, it will yield copper itself. It will also yield, that's the element, nitrogen 4 oxide and oxygen. So these are the different ways in which these compounds react with heat. And the last equation here is ionic reactions. Lest I forget this, thermal decomposition of potassium triazochlorate 5, that's KClO3, by heating also yield oxygen and potassium chloride. This is used in the preparation of oxygen in the laboratory. Then we have ionic reactions. What are ionic reactions? Under this ionic reaction, we have oxidation and reduction reaction, but I'm going to focus on the ionic reaction as a whole. In the ionic equations, dissolved ionic compounds are expressed in form of dissociated ions. Like if I want to write sodium chloride now, if I'm writing this sodium chloride is neutral and is a compound. If I'm writing it in dissociated form, it will be sodium ion, then chloride ion, using their charges. So to write a ionic equation, we start with the chemical equation first. Then we rewrite the soluble ionic compounds that they as dissociated ion. For instance now, some ions do not react. generally. So we need to understand them. We need to understand the solubility rules. They remain dissociated in solution. They are we call them spectator ions, which are cancelled out. For instance, now, in the solubility rules, we have all sodium, potassium, and ammonium salt being very, very soluble. All triazonitrates are also soluble. All triazocarbonate are not soluble except the triazocarbonate of sodium, potassium, and ammonium. So with the knowledge of the solubility rules, even the tetraoxosulfate of calcium, barium, those ones are not easily soluble. And we need to understand this, the principle behind the solubility rule, to be able to write ionic equations. So that, for instance, now let's look at this reaction. Hydrochloric acid reacting with sodium hydroxide to give sodium chloride and water. This is a normal equation. That is, this breaks down H plus chloride ion, Na plus OH minus. Na we have to Cl to give you NaCl. They cancel out because they carry equal number of charges. While H and OH we have to give you water. Now, to write their ionic equation, hydrochloric acid is soluble in water to form an aqueous solution. So we write it as H plus and chloride ion. Sodium hydroxide is also soluble to form aqueous solutions. So we write it as Na plus, then OH minus. So this breaks down, but looking at this, water is already water. It will not break down in water to form H and OH again. So we write it as liquid, is a spectator ion. We are not breaking it down at all, though other substances can dissolve in water. So the ones that are not breaking down are separated, or they are cancelled out. The ones that are breaking down are cancelled out. That's the Cl and Na on both sides, leaving H and OH behind to form water on this side. So we end up having H plus, that's hydrogen ion, and hydroxy ion on the reactant side, reacting with water. So this is just the ionic equation of neutralization reaction, which is entirely different from the normal chemical equation. Now we also have this another example, which is precipitation, and the reaction between silver triazonitrate 5 and sodium iodide to give silver iodide and sodium triazonitrate 5. Silver iodide is not soluble, that is insoluble, so it remains a solid, not aqueous. Is a solid. But sodium iodide, because all sorts of sodium are soluble, sodium iodide is soluble, silver nitrate is soluble, or triazonitrate are soluble. Here, so sodium nitrate are soluble. So when you break this down, we have silver ion, Ag plus, NO3 minus, Na plus, I minus. Then silver iodide is not broken down, so we write it as Ag, I. Then Na plus and NO3 minus being broken, they are ions. So we can break them down. So after cancelling out those ions, we have the spectator ion, which is silver iodide, and we also have the other ions here. We write them out as this. So this is the ionic equation for this precipitation reaction. So I want you to watch out for the aspect of treating past questions very soon. I will show you the past question, you treat them, and then we'll come back together after pausing the video to solve the questions together. Hello students, welcome back to the revision class on types of chemical reactions. So as promised, I want to solve the questions extracted from past questions. The first question here is, which of the following metals would readily displace hydrogen from steam? Now, there are different equation of reactions, and there are some reaction that does not occur. For instance, now, silver, copper, they don't react with either steam or cold water to liberate hydrogen or form hydrogen. So, lead reacts with steam. Magnesium too reacts with steam, but the magnesium readily reacts with steam compared to unlike lead. So the best answer here is magnesium. Magnesium here reacts with water in gaseous form to form magnesium hydroxide and also forms hydrogen gas, while lead will not liberate hydrogen gas. Now, the next question is, on heating the following trioxocarbonate 4 salts. On heating, the following trioxocarbonate 4 salts decompose to give solid residue, except have described this in the previous class that different trioxocarbonates decomposes. This is under decomposition reaction to give different products. But there are some trioxocarbonate that does not decompose, and they are the trioxocarbonate of sodium, trioxocarbonate of potassium, trioxocarbonate of ammonium. So the word except here, they said all those trioxocarbonates decompose except one, which is ammonium trioxocarbonate. Its trioxocarbonate does not break down, while the trioxocarbonate of calcium, lead, and zinc breaks down to form their oxide and also carbon 4 oxide. That of lead, that of ammonium, that of sodium and potassium does not break down by heating. The next question, so the best answer here is A. The next question, consider the following ionic equations. This is an example of an ionic equation. What is the value of N here? The N here represents the coefficient of the number of electrons to balance the redox reaction. This N here now is what we are trying to calculate. We will do so by calculating the total number of electrons on the product side, and on the reactant side. So the net charge here is -2 plus, the net charge here is +1, but we have 14 of that +1, that's +14, plus the electron here is unknown, so we'll leave that. Let's say plus x. Then from this side we have the net charge as +3, but we have 2 of such, that is +6. Then we have 0 here, nothing is on top here, +0. So on this side we have 6, while on the other side we have -2 plus 14, and that is 12. So what can we do to make these two sides balance? If you add 6 electrons which are negative to the side of 12, you end up getting only 6 left, which will be equal to the other 6. So the number N here is actually 6 electrons. We do so by calculating the charges they carry, and when you see a compound carrying no charge, then it means it is neutral and has oxidation number of 0. So this is 2019 number 39, and the answer is B. The next question, consider the following half reactions. What's the half reaction? Aluminium loses its electron to give 3 out, and this is the electron given out. After losing electron, it becomes an ion, which is Al3+. Copper gains electron that it has lost back. It gains the 2 electrons it has lost. But after gaining, when they gave out, they became ions. By gaining back, it becomes neutral. So loss of electron is actually oxidation, while this is gain of electron, and that is reduction. So this represents half reaction, half reaction. So the overall equation of this reaction is what? How do we write overall equation? By merging the two together. The total number of electrons here is 3, while the total number of electrons here is 2. So to get the overall result, we have to make the total number of electrons equal. So if you have aluminium plus 3 electrons here, if you multiply it by 2, you have 2 aluminium ion and 6 electrons. And if you multiply this by 3, we have 3 copper 2 ion, we have 6 electrons, and we have 3 copper. So if this cancel out, electron will cancel out electrons. So on the reactant side, we end up having 2 aluminium plus 3 copper 2 ion to give 2 aluminium ion plus 3 copper. So the best answer here is C, option C. I want you to practice more questions on this redox reaction. It's actually simple, just by balancing the number of electrons, and then we gather the reactions together. The next one, the gas produced when copper trioxonitrate 5 was heated. When copper trioxonitrate 5 is heated, we usually get copper oxide. This is under decomposition, thermal decomposition. When they are heated, we get copper oxide, we get nitrogen oxide, and also oxygen. So the answer here is B. But if it were to be a very reactive element like sodium or potassium trioxonitrate, we end up getting only the dioxonitrate, that is sodium NaNO2, and we also get oxygen. We won't get nitrogen oxide. And it should to be elements. Okay, I think this is below hydrogen, so we are not getting, yeah, we are getting this. But if it were to be below other elements like silver nitrate, if they are heated, we end up getting silver, nitrogen oxide, and oxygen, silver, gold, mercury, and so on. Now the best answer here is B. Now from there we move on to the last number, which is which of the following equations represents a redox reaction. The first question here, haven't been taught the types of chemical reaction. The first question here is like a double displacement, like silver displaces potassium displaces silver, because potassium is more reactive compared to silver, to get KNO3. And then chlorine displaces trioxonitrate. In this case now, it displaces trioxonitrate from silver. That's chlorine taking over this position to have this. So this is displacement and double displacement. The next one is trioxonitrate acid and sodium hydroxide. This is neutralization reaction, and it's also like a kind of displacement, double displacement reaction, because sodium is powerful compared to hydrogen. It displaces hydrogen, and also hydroxyl displaces trioxonitrate 5, and so we have this neutralization reaction, but it's a displacement reaction. The next one is thermal decomposition by heating calcium trioxocarbonate 4. We end up getting calcium oxide and carbon dioxide. And lastly, hydrogen sulfide and sulfur oxide react together to give you water and sulfur. So in this case, we can see that oxidation is a removal of hydrogen and the addition of oxygen. So the two definitions we are considering here are hydrogen and oxygen. removal of hydrogen, addition of oxygen. Now we will see here that oxygen has been lost from sulfur oxide to give you sulfur. Removal of oxygen is reduction. Addition of hydrogen is also reduction. Addition of oxygen is oxidation, and removal of hydrogen is oxidation. So if you look at hydrogen sulfide, it has been oxidized to water because oxygen has been added. And if you look at sulfur oxide, it has been reduced because oxygen has been removed. So in this case, this is a redox reaction, which means oxidation reduction reaction. So the best answer here is D. Well done, and thank you for paying attention and waiting till the end of the class. I want you to treat more questions on this topic. I wish you all the best.